because of my beautiful voice, I will just be a quick introduction of David Carboni, who's CTO at Policy and Practice. He's been volunteering with us for many, many years, almost since the beginning, I think. And has been an integral part of our platform team, keeping everything afloat so that things don't crash. And well, pass it on to David.
Good stuff. Thank you, Michael. So yeah, I'm David Carboni. I've been working with Policy and Practice sort of on and off for a few years. So I did a little bit of consulting for them and eventually joined permanent. And there are, I guess, a startup / scale up in London. So they're looking to move from that kind of startup journey to being a more sustainable DevOpsy technology focused company. So they have about 3, maybe 4 digital products, mainly for the local government space, but kind of spreading out from there. But they, I guess the interesting sort of technology part of the journey is this move from server full and manual processes to serverless, and so I've kind of dubbed this the journey to zero IP. Because I've noticed that the more you have serverless services, the less you have to worry about IP addresses. So it's an interesting indicator of how serverless you are is probably how many IP addresses you have to think about. So this probably gives you a pretty good picture of my mindset for most of my years in technology, which has been many. I think I've just found that certainly on the technical side of technology, the challenge is complexity, and things are too complicated, they're too hard to work with, too hard to change. I sometimes say legacy is anything you can't change, even if it's just been released. So the real challenge and the way that I've approached my career in technology is, could we just make things simpler, because it hurts less apart from anything. And when it's simpler, there's just less places for bugs to hide, and there's less chances for people to get it wrong. The more complicated you make something, the more opportunities you provide for something unpleasant to happen. So I'm really all about simplicity. So I kind of take the sort of design view that white space is probably the most important part. So when you're building a system, everything that's not there is where the value is. Whereas I think more traditional people I've seen over the years, generally the more complicated an architecture diagram, the more value one believes one is adding. I take very much the opposite view, because the more boxes are on there, the more problems you've got. I think at some point I invented a scale of cloud pain. I think there's a video somewhere on the internet about it, where I essentially said if you have any kind of infrastructure running in the cloud, then you can sort of give that a score of 0 for how good it is. For every IP address you have, you subtract 1. If for every server or EC2 instance you have, subtract 10. For every container you're running, maybe subtract 5. And for every Kubernetes cluster you're running, subtract 1,000. And that will give you an idea of how bad your infrastructure is. So the best possible infrastructure is the one that doesn't cause you any problems. So I have some pretty opinionated views, but basically the simpler your infrastructure, the less problems you will have. And that tends to be where I come from. So just for kind of a little bit of fun, bit of cheeky sake, for those who know, we've got AWS, we've got Azure, and we've got GCP. And there's probably a bunch of others who think they're clouds, but they don't really count. So I sort of wanted to locate it on that. If you're familiar with the adoption curve, this is kind of mentally how I see the landscape. So if you're somewhat esoteric and interested in how the internet works and what's coming next, you're probably using GCP. If you're a very large corporate trying to steer oil tankers and build bridges and the like, you haven't got time to be useful, so you're probably using Azure. So probably that middle of the market, AWS, it's the original, it's the big one, it's the one everybody knows. So for various good reasons, the Policy and Practice, my company, we use AWS. I have actually used Azure in the past with a central government department. I ran screaming and swore over my dead body will I ever use it again. So that's just me. I have also used GCP. I actually did their architect certification, which was particularly interesting because as most certification programs, if you go to an AWS certification program, the answer is always AWS. And the Google one, the answer is not always Google. So it is actually their top architect certification is actually testing, do you have experience? Do you know what you're doing? Not just have you learned Google Cloud? I always thought that was pretty interesting. But actually AWS, very solid, straight down the middle, horrifyingly complicated. All the others are about the same. So there is no simple, easy to use cloud. Although there are some better ways to use it, and I hope we'll get to some of that in this presentation. So the normal world of technology, to me, this is what it feels like. So let's say, and Michael and I have had many conversations about this. So this is a slightly tweaked and made up story, but let's say you just want to host WordPress, right? So PHP application, stick it on a server. Surely that's easy, right? So we're going to need probably an EC2 instance, so some kind of server to host it on. And we're going to start paying 24/7 for the server. The more power we need, the more we're paying. It gets expensive pretty quickly. And we're also going to need a database. So the natural one to go for is Amazon RDS. So it's a nice managed database. They mostly look after backups and what have you for you. But again, you're paying 24/7. The price rises quite quickly. Even in this picture, you can already easily spend a few £100 a month just to run WordPress. So what does that look as we actually start to build that into an infrastructure? Well, we're probably going to need some load balancing, so some kind of internet-facing network kind of ingress. We're probably going to need some EC2 auto scaling. So if we think we're going to have some traffic, then we probably do want AWS to manage the number of instances that we're running. So that will add more EC2 instances as the traffic goes up and shut them down as it comes down. So again, a bit more cost there. And then we're probably going to need an elastic block store, some kind of storage to attach to our EC2 instance, because being a traditional piece of software, WordPress expects to store files on the local file system. So, okay, so let's start turning this into an actual infrastructure. So we've got our auto-scaling group around the outside. We've got our EC2 instance in the middle. We've nominally installed WordPress. We've connected to our block store. We've got our database, and I've just sort of put load balancing out to one side, and it gets complicated. So that's, you'd think that was the basic infrastructure, but it doesn't really stop there. So because now you're thinking about, how am I going to do patching? How am I going to do monitoring? Possibly how am I going to do backups, depending on whether you've got your backups turned on RDS and EBS. And these become manual processes. They're things you have to worry about. They're things people forget about. They're things that go wrong, especially things like security patching. So, once that's a couple of years out of date, we're probably in fairly big trouble. So, and I've put them in red because for me, red means this is a manual process. This takes people time. This is expensive. So, but obviously it doesn't stop there. We've got a little bit more to add to this. So now we need to put all of this inside a VPC or a virtual private cloud. So this is VPC. Amazon have given everything interesting names. A VPC is sort of equivalent, in my mind, to a data center. So you're software defining your data center and saying, right, put all my stuff in my data center. Not all resources have to sit in a VPC, which then gets confusing. But for the sake of EC2 instances and RDS instances, that's all going to go in a VPC. But it doesn't stop there, right? So now we need public subnets and private subnets. So this is where you really get into the IP address world. So you need to know, what's in your public subnet, what's reachable from the internet, what's in your private subnet, what should not be reachable from the internet. You're starting essentially to set permission boundaries as you start to build up this picture and say, what's available to the public, what is not routable for network traffic. And then we go a little bit deeper. So now we have to start adding security groups. So you put a security group around your RDS instance and your EC2 instances. And that effectively functions as a firewall. So you now need to start defining what can access what. And that's it's probably going to block the network traffic that you do want. So you're now going to spend about 2 days figuring out why your WordPress can no longer access your database. And cursing and swearing as you work your way through the AWS console. We, by complete stroke of luck, in the last week or so, discovered something called the Network Reachability Analyzer, which is an entire tool in AWS just to figure out what can talk to what and why it's not working. So we were lucky; it probably only took us a day or so to figure out some of the connections that we needed to make. At the time, we were peering VPCs between public and private subnets. It was, yeah, you'll see the picture later. It's quite complicated. So, but it doesn't stop there. So once we've got security groups, we need to start adding rules. So now our security groups have got rules about what inbound and outbound traffic is allowed. You need to get those rules right. You need to be filtering on the right IP addresses. You need to have a pretty good mental model to know that you're not allowing traffic that you should be blocking. And you're probably going to scratch your head for quite a long time figuring out why is it the traffic that I do want is being blocked, and why is AWS not telling me what's going on here. But again, it doesn't stop there, because you're probably going to need an internet gateway to perhaps to allow the EC2 instance to get out to the internet, pulling patches and updates, what have you. Otherwise, you won't be able to. Even if you log into it, you won't be able to patch it and update it because it will just fail to connect to the internet. That means you're probably, when you create VPC, you're probably going to get 1 to 2 NAT gateways, which I believe cost about £50 a month. So you're likely to be, the minute you create VPC, you're probably adding £100 to £200 worth of costs, depending on how many subnets and availability zones you've got. That doesn't stop there, because now you need a route table. You need to know where all this traffic is being routed, how it gets to the internet gateway. And then you're going to need another route table down here. So anything in your private subnet that needs to reach the internet, for example, if RDS wants to patch itself, that needs a route to the NAT gateway to get to the internet gateway to get to the internet. It's building up a pretty interesting picture here, because really what we wanted was WordPress, and now we're just drowning in infrastructure. So you can sort of see that this is why, for me, simplicity is a big deal. This is why the zero IP infrastructure becomes a sort of really interesting kind of quest to go after. How can you redesign what you do so that you're not constantly drowning in complexity? So basically, this has to stop, right? We need to get rid of this. It's great fun if you just want to mess about with AWS. It's really not useful when you want to get a job done. And I do both, because I love messing around in AWS or Google Cloud or whatever, and I do that for fun. But also, when I want to get a job done, I am literally cursing and swearing, because I do not like any of this stuff. It's all getting in the way of me getting what I want done. So what's the hope? Like, what would be the opposite version of this? So for me, this is, so I did actually spend many months working this out. So it'll look quite simple on the screen, but actually, there's a lot of time spent sort of honing and filing down and chipping away every piece of complexity I can eke out and remove, until you can get to that final picture that is, do you know what? It's really simple. It's really neat. It's really secure. It does what it needs to, and it's not doing anything. It's essentially just got rid of all the externalities that we're not interested in. So if you've heard the word serverless, you've probably heard the word AWS Lambda. So this is a way of executing code in AWS. And it's kind of quite a bold way of putting it. But what that means is that you, at least theoretically, it's not perfect, but at least theoretically, you can get to a point where the one thing you need to care about is your code and how it runs. And the fact that it runs, all the networking, all the permissions, all of the infrastructure, everything it takes for that code to run is taken care of for you. So in a CI/CD continuous integration deployment world, which I do a lot of at work, you will work on your GitHub repository, you'll run your linting unit tests, what have you, locally, you build a package, you upload it to, you probably check it into GitHub Actions fires up, builds the code, packages it, passes it to AWS Lambda, and that is the end. That's your entire workflow. So the workflow from a developer's point of view becomes, I make a change to my code, I check it in and push it to GitHub, it runs, the end. And that is just, it's a sort of miraculously different way of working. What I still haven't got past with Lambda is that there is this sort of, depending on what technology you're using, is probably a 1 to 2 minute build time on GitHub Actions. So you do have this kind of quite long cycle time for every change that you actually want to deploy. So that means I tend to work with writing more unit tests locally, or just running some of the functionality from my local machine, so I can get a very fast turnaround time for the development. And then when I'm ready to see it running in the real environment, then push to GitHub, 2 minutes to build, and then test it in the real world. Now, what's interesting is it's very important to expand the definition of serverless. So serverless is, to me, it's any service, generally speaking, it's any service that does not require you to know about an IP address. So it will tend to work at the DNS level. So if you think of, so AWS Lambda is an API. If you, there's, it does not have, it does technically have a network interface, but it never gets an IP address. So you cannot address an AWS Lambda in the way you can address a server. Some of the other services that are worth thinking of are, anything which sits behind an API but does something useful for you. So in the Google Cloud world, that would be things like Cloud Vision, Cloud Speech Recognition. These are quite simply APIs that you call that do work for you. There is no server, there's no 24/7 cost. You're paying literally for traffic and or storage, depending on what you're doing. So I wanted to pull out some of the big boys of serverless in AWS. And something I did get from the Google Cloud certification that has really helped me understand, is a very helpful way to parse cloud infrastructures, is that you can categorize everything in your infrastructure as either compute, storage, or networking. Those are the 3 fundamental classes of cloud components. And what's really useful about that is if you think about a traditional server or a PC or a laptop, you have the network card, you have your hard drive, and you have your CPU, and they're all bundled together in this box. So the way traditionally in the past IT has always been done, you always think of this bundled box of all 3 classes on one single server. And what the cloud does, and I think Google probably led the way with this, just shifting that mindset from how many servers have we got to, no, what are our services that provide network, compute, and storage, and how do we assemble those different services to deliver the actual end result that we want to get to. So the ones that are interesting kind of headline ones in AWS. So Lambda is basically your unit of compute. So it's stateless. There is no storage. Networking is pretty much out of your hands. There's just not a lot you can do with networking a Lambda. When you have to, it gets painful, and I'll show you that in a minute. So it's a unit of compute that will start on whenever Amazon wants it to start. It will run your code in response to an event sent to it. So some of what I'm doing, an HTTP request comes in, I consider that to be an event. That would come through an API gateway, and that would be the trigger for the Lambda. The Lambda does the work, accesses what storage it needs to, return the result, and then as far as we're concerned, that disappears, ceases to cost any money. So rather than paying a couple £100 a month for an EC2 instance, you're paying £0 a month to have a deployed Lambda, and you're then just paying for traffic. So the amount of traffic, the amount of time that Lambda is running, and that's your only cost. So if you've got either a very uneven or spiky workload or a very lightly used service, you're likely to be spending pennies or less to run this thing. So there's this kind of tantalizing world where could we really start to collapse down the cost and also really collapse down the complexity that it takes to just run the code that we're interested in. So out to the left there, so CloudFront, that's kind of Amazon's CDN, just quite a useful globally distributed network, picks up traffic, routes it in, it integrates with Route 53 for DNS, ACM certificate management, so AWS will quite happily generate SSL certificates for you automatically. CloudFront is able to route to an API gateway. API gateway is able to use a Lambda to provide its functionality. So there you've got your ingress, your routing, your compute, and then Lambda will quite happily talk to things like S3 buckets. So if you're storing files or unstructured content, or something like DynamoDB, which again, this is just a pure API. There is no server. You're just speaking to it, and you're sending requests, queries, responses, what have you. So all of these components here, if you have no traffic and no data, this entire type of infrastructure will not cost you any money. And on my own side project, so Michael's heard me say this, I run them for $1 a month because it costs $1 to have 2 hosted zones in Route 53. So just having 2 DNS zones, but 0 costs across the rest of it. If I have a little bit of traffic, it goes up to maybe $1.10. And you can see that the difference between, like as a company, I think we spend easily £5,000 a month on AWS. So there's a huge disparity between what's achievable if you can shift the way that you think about infrastructure. So if we come back to this, if we actually deconstructed this and worked our way back to serverless and start to replace some of these components, I'm hoping this is going to work. I had a bit of fun putting this together. So the first thing we're going to do is get rid of all of that manual effort with patching, monitoring, backups. All of that's off the table, because once you start moving to serverless, it's Amazon that is dealing with all of that underlying infrastructure stuff. So we really only care about our storage and our compute, and that the networking is correctly configured. And that's basically the extent of it. So that's gone. We start taking out route tables because we don't need those. We take out our NAT gateways. We don't need those. Internet gateway goes away. Then we're going to start taking out all our security group rules. Security groups can go. We no longer need our auto scaling group because Amazon's going to scale everything for us. There goes our EC2 instance because we don't need that anymore. Take out our subnets, take out the VPC, and now, okay, let's get rid of the load balancing for now. Suddenly, I'm looking at this going, I could almost live with that. So let's pull that in a little bit. So let's put S3 in place of disk storage. Let's put DynamoDB in place of RDS. Now this is kind of where it breaks down, because WordPress, being a traditional piece of software, does not work with DynamoDB and struggles to integrate with S3. But theoretically, if we had a web application that integrates with DynamoDB and S3 for essentially database and file storage, then this is almost the extent of our infrastructure. So let's put Lambda in there, and so we're now kind of hosting our web application on Lambda, and we've got API gateway to route traffic in, and that actually is a minimum viable architecture. It's possible to run a website just using that. So even though it's called API gateway, you can still return HTML from it. It will function as a website, and I have done this. If you want to go a little bit further, you can put CloudFront in front of API gateway, and that just gives you, I guess, a little bit more kind of caching. There's some nice things you get from that, for example, where you can only route certain CloudFront requests to your Lambda. So what I've seen from running various services is that every couple of days, someone will come along and try and give you a good poke and see if your WordPress instance is dodgy, and they could crack in there. And what that means is it ends up invoking the Lambda 20, 30 times. Not a big deal, but if you want to filter out those requests, CloudFront the way I've set up CloudFront will help just kind of offload those requests. So you basically only get the requests you're interested in invoking your Lambda. So again, you're just shaving off extra bits and bobs of cost from there. And that, I mean, this pattern is pretty much where we're going with the company. So not everything is there yet. So I'll show you we've got one in transition at the moment. But pretty much this is the model for running all our services now. And all of these components talk to each other via IAM, so Identity and Access Management. So these are permissions set at the AWS level, not at the network level. And that means we can't get IP ranges wrong. We can't get security groups wrong. We can't leave something misconfigured or slightly too open or in a public subnet when it should be in a private subnet. We literally say, the arm bone connects to the elbow bone, connects to the finger bone, and AWS will just make those permissions work for us. Nothing else has permission to access anything unless AWS says so. So I think one of the really big ones for me is just taking all of that permission model off the table. You no longer need to be able to mentally and arithmetically work out your IP addresses, CIDR ranges, inbound and outbound security group rules. All of that is just gone, which I just think is like a fantastic way to live. So, so we've gone from there, which was that's a lot of cognitive load to handle, and now we're here, and I'm just like, okay, this is something. So one of the ways that so I think a lot about teams and dynamics, building teams. If I've got a team of 50 people, I have a coordination problem. Chances are, if my architecture is that complicated, in a decent sized company, it's going to take me 50 people to manage it. I'm going to need network admins, DBAs, all sorts of people crawling over this, trying to make sure it's right, trying to keep it right between multiple environments, looking for configuration drift. If I do this, I can have a team of half a dozen people who punch above their weight and deliver a service that's more resilient than some of the largest companies in the world. With half a dozen people, that's really cheap. It's a lot of fun. Great for the company. It's great for the team because everyone gets a lot of responsibility. You're not just the guy who fixes the security group. You can literally be the guy who built or girl who built the entire infrastructure. So, so I see this. It's good for companies. It's good for just how much your head hurts, and it's good for just not needing to know a lot of stuff. I occasionally will have to work out, an IP range or a CIDR block or something like that, and I can go and Google that, and I can do it when I need to. But most of the time, ain't nobody got time for that. I'd rather be doing the fun stuff. So this is our actual in progress, real live transition. So I'm hoping nobody's going to mind too much that I'm showing this off. But what you can see on the left, so what do we have? What we are transitioning is the back end of our flagship product. So this gets, I don't know, 15, 20, 30,000 customers a month coming through it. So it's pretty highly used service. It's been running for about 10 years. A lot of the code in it is quite, just naturally, it's a 10-year-old code base. It needs a good revamp, so that's what we're doing at the moment, just having a good spring clean. It's currently running on, so it's containers running on Fargate, which is at least a step up from EC2. So containers on Fargate with an RDS instance, which you can see at the bottom left there. And that RDS instance, that's kind of that's the headache. That's the thing we ultimately want to get rid of. So what we started doing, so we went through a few iterations, but the general plan is we are building out a parallel infrastructure using serverless. So we've got Lambda, we've got API gateways, we've got SQS, SNS, so messages, notifications. We've got a few external services we're integrating to via APIs. We've got S3 for static content up the top there, Route 53 for DNS, Amazon Cognito for user management, because we do not want to be looking after anyone's passwords. And that is definitely not something anyone wants to be doing. That's not something anybody wants to be doing anymore, is looking after other people's passwords, because the opportunity for getting that wrong is way too great. So what we've So what we're in at the moment is a sort of transitional phase where the existing architecture is still running off to one side and talking to that database at the bottom. We've started to build out our sort of CloudFront API gateway Lambda infrastructure. So we're building kind of the network and compute portion of the product, but we're keeping the storage portion essentially the same because we need to be able to work in parallel with the existing architecture. And what's really interesting about that is that we are in a service world. We're using our Lambdas. All of this is working beautifully, but in order to be able to talk to that database, every bit of complexity you see on the left that is not there on the right exists purely to talk to that database. So what you may or may not be able to sort of parse that, but we've got two VPCs going on. So the bottom VPC, this is where the database currently sits. So we're avoiding making any changes to the existing infrastructure, but we do need access to it. So we've created a new VPC, which is where all the Lambdas are currently sitting. They have to sit in a security group. We have to peer the two VPCs together to allow the traffic to go across. This is where we spent a good long day with a network reachability analyzer figuring out how to get that traffic to flow. Something we have learned is it is impossible for a Lambda in a public subnet to access the internet. This took us about a day to figure out. So we have to place Lambdas in a private subnet. We have to have an AT gateway and a route table to shift that traffic into a public subnet where it can then reach an internet gateway. Don't worry if all of that doesn't make a lot of sense. What I'm trying to get across there is that we've had to create an awful lot of complexity, even in a really nice serverless architecture, just to access that database. So the prize for us over the next couple of months is going to be, can we complete the transition of the code into Lambdas, refactor, clean up, prove to ourselves that in spite of all of this, actually, yes, it does work, and it does work really well. It can deliver the equivalent service to the current infrastructure based on the database. Then the challenge is, can we, on a live service, switch our DNS from the current infrastructure to the new infrastructure so that this becomes, so what we've got on the left becomes the actual way that we run our product. And then phase two, so kind of second half of this year, is can we remove that database and replace it with DynamoDB? And that moves you from the left of the diagram to the right. So again, VPCs are gone, security groups are gone, subnets are gone, private endpoints are gone, because a Lambda in a private subnet doesn't have access to things that it needs, like SQS queues or secrets manager or even Amazon Cognito. So we've had to sort of figure out and create all these private endpoints as well. So you see on the right, we've got this lovely clear diagram where almost all of it is vanished. And that to me looks like, that's the product that I want to run. That's the product I want to work on. That's the product I want my team to be proud of working on. And hopefully showing up to some nice tech conferences and boasting about how we did it. Ideally after we've had all the problems and got over them. So you can really, I think what hopefully you can see from that diagram is just having that one database, that one thing that is all tied up with IP addresses, subnets, and security groups, just instantly generates all this complexity, even in a really nice serverless architecture. And once you can kill that database, and Michael and I have had many discussions about this, because some of the things we're doing, we don't have the luxury of moving away from RDS. But if you can get to the right-hand side of that diagram, suddenly you're like, wow, this is a really interesting world. And there's nothing in there that needs to route traffic. We don't have to figure out IP addresses. It's all done at the AWS IAM level. And as I'll show you in a minute, we've been using the AWS Cloud Development Kit to do this. And so we're now able to generate multiples of this environment. So on some of our other products, we can generate multiple environments, which are all absolutely the same and maintains in lockstep, which is just fantastic. Like, if you've ever had to do that by hand, it is really painful. So so I wanted to touch a little bit on the Cloud Development Kit. So this is something that AWS have created So AWS have something called cloud formation, which is a way of defining your infrastructure using YAML code. YAML, yet another markup language, apparently. Now, it's really nice in theory. And if you've heard of things like Terraform, CloudFormation is AWS's version of Terraform, as it were. Those things are still really hard, like, are very complicated to work with. So what AWS have done is they've developed something they call a Cloud Development Kit. So this is literally a code library. So you will fire up your editor and you have objects or constructs, as they call them. So you can just say new bucket, new Lambda, connect Lambda to bucket. And in about 3 or 4 lines of code, you've defined an entire infrastructure, all of the permissions, all of the network routing, everything that's needed for a file landing in a bucket to trigger a Lambda to run your code. And it's just an astounding drop in complexity when you look at the CDK code, and then you look at the cloud formation code that is generated from the CDK in order to create the infrastructure. So just for fun, I went and looked at one of my sort of medium complicated projects. And so I just looked at the code. So we've got 263 lines of CDK code. So this is just literally just defining objects, creating relations between them, just saying, right, this object needs to talk to that object, but nothing else needs permission. And then I looked at how many lines of YAML code were generated from those 263 lines of CDK, and it was just shy of 5,000. So if I'd done that by hand, I would be having to manage 5,000 lines of YAML code, and instead I can manage it with 263 lines of just, in my case, just normal TypeScript code. And it's still complex. Like, it's still quite painful to work with. And Michael said, the guys talking about it in our session, but actually it's so much less painful to work with. There was a time where we were using Terraform, and just to get one thing done would take a week, whereas now the guys can like get 2, 3, 4 things done in a week quite happily. We know what we're doing. So I think what I wanted to illustrate here was just that, again, a massive collapse in complexity. Not only the move from server full to serverless, but also the move from manually created or cloud formation created infrastructure to CDK created infrastructure, where again, we're just, these are orders of magnitude of complexity that we don't have to deal with. Again, like my company is fairly small, it's about 40 people. Our dev team is probably only about 6 people, and we're trying to run and manage 3 or 4 digital products. And okay, we're hiring a couple more people because that is getting harder. But actually, when half a dozen people can do the work of a team of what in the past would have been 50 or 100 people, I'm really proud of the amount of work that we are not doing, if that makes sense. The amount of work, the amount of kind of make work that we don't have to do to make this happen. We can really focus on the good stuff. So if anyone is interested, I thought I'd pop this on there randomly. So I've been collecting all of my favorite CDK patterns. So these are specifically serverless CDK patterns. So these are things like, I would like a Lambda that's fed by a queue, or I would like to build a website with CloudFront that backs off to Lambda. Or I would like to, I would like to create a container that runs on Fargate. So it's every time I keep coming across the same pattern, the same building blocks of these products that I want to build. So every time I build a new one, I stuff it in here, and so I kind of sort of somewhat cheekily open sourced it, and so it's kind of there for anyone else to use. It's somewhat my own brain dump, but if anyone else can and does want to get value out of it, it is there. It's also quite a nice way to get into the CDK and just see a little bit of, how does that work? How do you put it together? How do you integrate it with GitHub Actions? How do you get a Python Lambda to build or a TypeScript Lambda to build? How do you get that deployed? What's the infrastructure that goes with it? So there's quite a lot here. There's a bunch of code that integrates with GitHub variables and secrets. Because once you start building infrastructure, you realize pretty quickly when GitHub Actions needs to deploy a Lambda to AWS, it needs some kind of key or some way to access AWS to be given permission to do that. So there's quite a few nice pieces in there. Yeah, I'm not sure I can recommend anyone go to it cold, but do feel free to kind of ping me, or we'll come on to one of the sessions where we're often talking about it. So I think we're kind of coming into land there, but I just really want to kind of, just remember like how complicated and how painful this could be, and the promise of where that could get to. So if you have got a serverless architecture built with CDK, again, you could be creating 3 or 4 of these environments. Deployment times, a CloudFront takes a while to deploy, but if you're deploying this from scratch, within 15 minutes, you'd have your entire website infrastructure, SSL, available on the internet, costing you $1 a month. Like that's the kind of stuff where I remember the days when that would take you 6 to 9 months. So 15 minutes is a far cry from that. So yeah, it just makes me very kind of happy that this world is possible now. So just kind of really keen to share that with you guys. So yeah, it really is like, it's a whole new world, it's a whole new life. It's what is possible now is just on a completely different scale to even 5-10 years ago. So yeah, I kind of wanted to sort of pass on some of that enthusiasm. Not all companies are able to do it, but the prize is there, and it is available for those who can get stuck into it. And I would certainly recommend anyone who fancies it to have a go. So with that, that's me. But I just kind of wanted to open the floor for any questions, comments, any kind of resonance. Yeah, go for it.
I wanted to ask how what the easiest way is to create YAML documents for CloudFormation. Is it because I know that you don't necessarily need to use the CDK. You can also use the IAM management console and the CLI as well. So is there a reason why you use the CDK rather than the other 2 options?
Yeah, I think it's just partly just sheer complexity, partly because like I find it very natural to work with code to sort of create sort of structures and objects and give them properties and link them together. So I think, mainly it's just the sheer scale of it that so I was working with one of my more junior team members, so he's just building a small React application. So he just needed to deploy this. So I was like, right, let's buy a domain name, run up a CloudFront, connect it to an S3 bucket, and that will serve your React application. And we looked at it, and it was, with a bit of help from SCloud, it was about 6 lines of code. And within 2 hours, he had, and he's never done infrastructure before, so we just paired up and did it together. And within 2 hours, we had the whole thing running. And it was just like, wow, full on HTTPS, globally distributed. So I think that the way that the CDK has been very carefully written to generate the correct CloudFormation. I struggle to. I edit things like GitHub Actions workflows by hand, and I can cope with that, but they're never more than 100 lines. So I just I physically don't know how I'd cope with 5,000-10,000 lines of YAML.
Thank you. I have another question if no one else has.
Go for it.
I'm just thinking about the cost of everything. How do you work out how much, if you start using, if you decide to use a new resource, I don't know what, maybe a new S3 bucket or a new DynamoDB table or something, how do you work out how much it's all going to cost you?
Typically we don't. So we now with most of the serverless resources, they're cheap enough that they are they're pretty low down the pecking order of what one cares about in terms of money. So if you accidentally spin up a massive EC2 instance, you could easily be spending a couple of grand a month. If you accidentally create 6 DynamoDB tables but there's no traffic, that's going to cost you 0. Even if I I think I got one with like a couple of million rows and fairly high traffic. That was still only costing 200 quid a month, which, you know, for an individual, that's a big deal. But, you know, like as an individual, I don't have anything that has that much traffic. But the numbers are really quite small. So I think at some point I probably had a bug in my code. I think I accidentally sent myself 23 million SQS messages. It cost me about 20 quid, but you know, it's not the end of the world. So I think particularly in the serverless world, you'd have to work really, really hard to bankrupt yourself, or you'd have to attract quite a large cyber attack. And even again, then, you know, AWS has a whole bunch of limits in it where essentially you have to work really hard to to spend money. So I remember doing, you know, I was doing I was doing Google Cloud days. I was mucking around. I had a Google Cloud function, and I was pumping through literally gigabytes of zip files that I was unzipping and rezipping, and you know, pulling out duplicate files and stuff like that. And you know, after probably a month of pushing gigabytes of traffic through this thing, I think I had a bill for 30 quid, and I was actually quite proud of that. Wow. I was proud that it was even that high. Like it was, you know, it's hard to, yeah. So generally speaking, yeah, the serverless side, it just tends to be a lot cheaper. I mean, the other thing to do is, you know, set your limits, monitor your costs, you know, just look for any spikes. Generally speaking, we'll try it for a month, because okay, you can, you know, if it accidentally costs you £1,000 for a month, you know, as a company, you can probably deal with it. You're like, right, okay, retrospective, why did that happen? How do we not have it happen again? You know, let's shut that down, make sure we don't do that anymore. But it's kind of from month to month, we're monitoring the costs and going, right, what else could we take out? What else could we reduce?
Wow.
Yeah. Good stuff. I guess I appreciate it's probably quite a lot in there to take in, but yeah, sometimes there's one thing in there that just makes you go, huh, or you know, a little click or a resonance or a little thought that makes you kind of makes you go ping. I wonder if anyone.
I just want to say thank you, because at the charity I work for, I'm a project manager for a Pride based in Brighton, and I was just having a conversation. I've been having conversations with her for a while, but about this. The IT lead, she really wants us to switch to serverless, and this is amazing. Like this video's been amazing. This meeting, so thank you. And we're literally like, I can see how from this flow, although some of it's maybe gone over my head a little bit, like, but I can see how all this could be really useful for implementation. With this process that you described, this really streamlined process with Lambda, built out from that with WordPress, would I be able to create a merch store? Would that be suitable within that process so we can get transactions through a website? Yeah. Or would I need to add in, or would that add quite a lot of complexity to that infrastructure?
Yes, the main bit that's hard is translating code. So translating sort of maybe traditional web application code so that it runs in Lambda. And so that's a bit where I guess I have the advantage there, because I've got a really good development team and they're all up for it, and they intimately work with this code day to day, so they're quite happy sort of passing it up, pulling it out of the web application, transferring it to a Lambda. So it can be difficult to run, and Michael and I've had a little discussion about it. It can be difficult to run pieces of pre-built software unless they've been built or rebuilt in a way that can run on Lambda.
Okay.
So kind of while setting up the promised land, I think also it's important to remember that I think at the moment we're still kind of in the world where it's basically going to be custom software that can run on Lambda, and that's great if you've got the development team doing that, or a team who understands how to translate it into Lambda.
Okay. Yeah. Thank you.
Anybody have any more questions for David? Okay, well, thank you very much, David. It was a great presentation.
There was one in the chat, sorry.
Oh,
Ready.
Can't see the chat.
Chat thing. All right. She's asking, when we're talking about the minimum pricing, what is minimal traffic?
Yeah, I don't know, say if you're getting, I don't know, say 100 or a couple hundred requests a month. So I mean, like, I know some of my side projects, you know, it's basically only me accessing it because I'm developing it. But there's still probably, you know, a couple hundred, a few hundred requests in that. So yeah, so I'm paying 50 cents for a DNS zone, so a web address, or in one case $2 because I've got .com and .co.uk. So then, yeah, on top of that, we're, you know, a bunch of SQS messages, a bunch of Lambda invocations. A lot of that actually will probably just get eaten up by the AWS free tier. So, you know, probably up to, I don't know, 1,000, a few thousand requests a month. So I'm trying to think. I think I probably spent. I've got one of my own projects where I've got one DNS zone, so take out 50 cents. I think it came up in at $1.11 this month. So that means I spent 61 cents for, and I have actually got that thing hooked up to work. So it's getting constant traffic, like every time the developers are pushing stuff to GitHub. So, you know, I'm trying to measure these, if anyone's heard of the accelerate metric. So this is all about what's your cycle time, how fast are you getting stuff into production. So I'm, you know, measuring those metrics as we're working with GitHub. So that's probably got a few thousand requests a month, and that's still only, yeah, 61 cents, you know, excluding the DNS zone, but even then $1.11, and that, you know, it's pretty much a functional product. Yeah, hopefully that's it.
Let's see. And also, we talk about added complexities and endpoints and total access controls in IAM. Do you think this is all leading to better security?
Yes, absolutely. So I mean, when I'm being flippant, I say the way AWS works is you deploy a couple of resources. Like when you're doing it by hand, you deploy a couple of resources, you realize they can't talk to each other. Then you spend 6 hours trying to find the right permission. At the end of the day, you go, screw this, and just give everything full permission. And then you forget about it. And 3 years down the line, you wonder why, hang on a minute, this should not have access to that. And that, you know, because of the complexity of AWS permissions, it, you know, that tends to be, you know, what happens. The sheer amount of time it takes to get those things right, if you do want to get them properly right. I remember at some point I was literally trying to get everyone in the company to be able to set their own 2-factor authentication, just to switch it on and configure it for their own account in AWS for the sake of security. I think on and off over about 6 weeks it took me to get that right, because someone would log in and go, I can't see this bit, or it's giving me an error, and I'm like, I literally don't know what's wrong with it. So I did, you know, I'd pair up with a couple of people over a whole period of weeks until we finally got that thing right, so that people could even turn on their own 2-factor authentication. I'm like, you know, that alone, you know, was a massive boost to security. And then, you know, whoever it was, LastPass had their security breach, and, you know, suddenly we had to like just blitz everyone's accounts and force 2FA on everything. You know, like, had that happened a couple of months earlier, we were not in a position to get everyone switched on to 2FA because people just physically were not permitted to do it in AWS. So, and the CDK is, I mean, it's phenomenal when you say, you know, new Lambda, new DynamoDB table, DynamoDB table dot grant write to the Lambda, the end, and, you know, it will give you precisely the permissions you need. If you then update that code and say grant read write, it will go and add the permissions you need. If you switch it back to grant write, it will subtract the permissions that should not be there. So when you're running through the CDK, it's constantly adding and removing to give you precisely what you need without you having to figure it out. To me, that's just, yeah, like, that's the security dream, when the computers are working out for themselves what should have access to what, and taking it away as well as granting it. Yeah, I just can't think of a better way to have good security. And then again, when you're doing it across multiple environments, you know, making sure that those permissions are all kept in sync across all the environments. You don't just have that sort of manual thing where someone had to go in one day and fix something and then they forgot to put it back and then they left the company and nobody knew about it. And why is this database in the public subnet? There are all these sort of mysteries of configuration. Whereas when it's documented in the code, it's managed in source control right next to the application code. You can see precisely what this should be, why it's there. There's comments in the code explaining we had to create this endpoint here for these reasons. We're using this strange URL here for these reasons. We got this off this blog post. All the references and explanation is there in the code. Assuming you're developing it well and communicating to your future self. So yeah, if that helps, I think for me, security is very much the big one of probably the biggest win from this, because of the reduction in complexity and because it's being managed automatically. There's no substitute for automating things where you can.
All right, guys.
Good stuff.
Well, thank you very much
Yeah,
again,
welcome.
David. Any last questions? And then I have one last question for the audience, which is what kind of topics would you like to see in future talks? And everybody's quiet now. Oh, if you can't think right now, just ping me a message on Slack if you have any ideas. And we can work on that. Okay. So
Brilliant.
Thank you very much, everybody.
Thank you, David. It was an interesting talk.
Thank you. You're welcome.
It was great. Okay, guys. Thank you very much. Sorry, I cannot speak. Some more messages. I'm really bad at reading messages on the Slack, on the chat. Okay, thank you everybody for coming. Thank you very much, David. It was great. And like always, all of them will be back on the YouTubes, on the wherever we're putting them, but we'll have a link on it. So thank you very much and have a great weekend, everybody.
Good stuff. All right.
Thank you. Bye.
Happy Easter weekend.
Thank you.
Oh,
Good.
Yeah.
There we
well,
go.
thank you very much, sir.
Yeah, that was fun.
Trying to change the world.
Yeah. Oh yeah. All about that.
The simple code.
Yeah. Keep it simple and you probably will change the world.
Yeah, if only there's too many companies are set up around complexity.
Yeah.
No, don't say that. If you do that, oh, that's bad. If you do it like this, then we don't have a business model.
Gosh, yeah. Are you working today?
Nah, this is it.
This is it.
What do you?
Yeah, I'm going to get back to my because English company, so they're not working today. So I'm going to be back to my developing my apps and products this afternoon. I'm looking forward to a good run on working for myself today.
Well, that's good. It's just it's been my experience as I've been here in the UK. Most of December's a write-off. The last 2 weeks of December are a write-off. First week of January is a write-off.
Yeah.
Easter weekend is a write-off.
Yeah.
No matter who pretends it's not, it is.
Yeah.
It's like even if you're talking, even if your clients are hospitality,
yeah,
they'll be too busy. They don't care to talk to you, so it's a write-off.
Interesting.
So,
yeah.
this is what I've never understood. It's I've dealt with too many companies that just don't see the benefit in closing and kind of having employees use holidays. It's like, you don't trade, nothing's going to happen. That's 2 holidays gone.
Yeah.
That you don't have to try to jiggle things around.
Yeah.
But yeah. All right, well, have fun building apps.
Yeah, definitely. Good stuff. And yeah, thank you for the invitation. That was good fun.
It was a pleasure. I think everybody liked it quite a lot.
Yeah.
We'll
Yeah, I
see
like
what-
it when people are like, "Oh, this is interesting. It's made me think differently."
Yeah, well, I mean, I think it's the first one in a long time I've seen people take notes. So I
Great.
think
Yeah.
it'll be, I think be good. But the feedback looks very positive. So
Excellent. Good.
thank you very much.
Yeah.
And yeah, I think I'll point it to Alistair because I keep telling him it's like, wow, going back to the cupcake terminology.
Yes. Nice. Yeah. Is this one going to be on YouTube? Because I'll tweet it and share it a bit.
Yeah, I think Charlotte's going to do a bit of cleaning, put a title, make it all posh, and
Nice.
I'll, when it comes out when it's ready, I'll ask her to get in touch with you.
Yeah, great.
And she should be getting in touch with you anyway, but I'll remind her.
Good stuff.
Very nice.
Yeah, she seems keen and fresh.
Oh yeah, no, well, she's great. She came through Kickstart
Okay.
and she stayed, and she's 19, I think.
Wow. Yeah.
So very keen to learn, very keen to,
Yeah.
and she's more on the social side, on the not necessarily social media, but like on the marketing side. I think that's what she enjoys the most, and that's what she's doing now.
Great. Yeah.
So she does all the video editing at this point, which is great because then I don't have to do it.
Yes. Nice to give that away.
Well, it's also it's a matter of setting expectations, like everything. Say some people don't appreciate how long these things take.
Yeah. Yeah.
And it's like, we're going through some posts from movie makers,
Okay.
and they were what you call it? Some of the movie, it takes about 2 times as long to edit a movie than it does to shoot it.
Yes. Yeah.
And that's best case scenario. If you have things like Avatar, where it's like 100 days shooting, 500 days editing,
Yeah. Yeah. Well, even just doing, if I go out and do a drone video, I'll be out for an hour filming, and then I'll spend like 4 hours editing for a 1-minute video.
Well, I did a video with graphics. I think it's a 30-second video. Took me like 2 weeks.
Yeah.
It was ridiculous.
It's fun, but it is time consuming.
Oh yeah. Especially with all the things you can do with the tools.
Yeah.
All right. Well, thank you very much, sir. Enjoy your weekend.
Likewise. Happy Easter weekend.
You too. All right.
Good stuff. All right. See you soon.
Yeah.
Thanks. Bye.